Let's go through the code 3186. Maximal total damage with spell casting. Give us a integer array power. And we want to return a long that is the maximal total damages. So what does that mean is that if a magician decide to cast a spell with damage power I, then he's not able to cast the damage of power I minus 1, power I minus 2, and power I plus 1, and power I plus 2. So that means if we select a number, for example, we have select in this array, there is 2, 2, 2, right? So if we select 2, that means the magician cannot select 1, right? Any ones cannot be selected. And also 3, 4 should be skipped. And he's able to select 5, right? And the same thing for select 3, right? Then 1, 2 cannot be selected. And um, 3, 4, and 5 cannot be selected, right? But the same number can be selected multiple times. For example, I can select 1, all of the ones, right? So it is asking the maximal sum, right? So for this question, let's look at the data range. Yes, the data is very big, right? If the data is small, possibly we can just have array with this data size. For example, we have data is just in the range to 10 to the power 5, right? Then we can just have array with this possibly 10 to the power 5, 1 plus 1, right? And this is just a traditional house robber. But this data is very big, right? Apparently, we cannot have this kind of array, right? So what I was thinking about is that we can, of course, that this is also a house robber problem, but we should not use array. Instead, we can use something like a tree map, right? So and also because for the same number, it may have multiple times, right? Of course, we can sum those numbers at first iterations, right? This is another part for this is the group iterations. So um, so what we think about is that first thing is we think about is we use the tree map. Tree map. So tree map, the key will be the numbers. For example, this one, right? And value, what will the value to be? The value is that if we have this number, what's the maximal total damage we to this number? Actually, we can sell the maximal total damage when we iterate to this number to the values. So for this number, it can has options to select or not select, right? Just has a hot rubber. We have two choices: select, not select. We still save the maximal or maximal total damage when we iterate this number, right? So so if of course for this number we have select or not select. So if this select, then we just have from this tree map we just use a DP DP this number, for example we iterate each number, right? Power I. Then so what we saved in this tree map, we should get this one minus 2, right? minus 2, but the thing that it is possible this power I minus 2 does not exist in this power integer array, right? It doesn't exist. Then we use the tree map floor key to do this, right? Use this one minus 3, okay? Because one if current select, right? Minus 1, minus 2, minus 3. We use this one's floor key, right? And so that is we can call based before, right? And plus current power. And then if it's not select, then the base is that we just get the last entry, right? So and in the end we just put current power I and the base pick or not pick result to our tree map, right? So let's use these kind of approaches first. So we know because we want to put all of these numbers together, right? And we can use a group iterations. So we need to sort this power array, right? So we can have arrays sort power. As we talk about, we can use a tree map integer. Let's have a result to be long, right? BP equals new tree map. So the key will be the power I, right? And the long, the value will be the max damage up to this power I, right? So we put because we always want to have the floor key, so we can put a dummy head here. Put integer mean value, and we know this current sign is 0, right? So int n equals power dot length, and long we'll have do we need a long? We don't need a long we just need to have a count. So we can have a count, right? For every group, we have a count equals 0. So what we do is that for int I equals 0, I smaller than n, I plus plus. So we're going to have a count should increase, right? So if I equals n minus 1 or power I doesn't equal to power I plus 1, right? So we reset the count. So this is the group iteration, right? So, but here, what we do is that we need to get the best before, right? Best before should be dp dot floor entry should be power I minus 3, right? Get a value. And we are going to have two choices for current one, right? Long pick equals based before plus power I, right? And long not pick equals dp dot last entry pick last entry dot get value. And then we put dp put power I max dot max pick, not pick. Right? So this will be our code. And in the end, just return dp dot last entry dot get a value, right? This is not power. I actually we should because we should have counts, right? Multiple by counts. So um long. Actually we should have one L, right? One L multiple by. Doing like this, right? We use a tree map. Um, it will we have sort for this array that will here that will be n log n for sorting, and the tree map for every operation that is n log n, right? And space will be O(n) space. But let's analysis. Do we actually need this tree map? We'll find in this tree map, actually, we only need to, when we iterate this kind of every number in the power, right? We just need uh, to look at whether in this kind of map there is power -1, power -2, right? And also power -3, right? Because if we do not select current power I, we need to have a max of previous three. Um, and if we select, right, select, um, we cannot select this, right? Then, then what we do is that we try to see if we can select this, right? But the problem is that this number may not exist uh, in our power, right? P minus 2, 1 and power -2. So what we do is that, but we can still keep only three numbers. The P, let me see. This is P1. Let's say this is P1, P2, P3, right? So we can do, we just need to store three numbers. The previous smallest three numbers, right? And we iterate. If P3 already is smaller than current P -3, then we just use P3, right? The worst case is that those three numbers are consecutive. And we try to see whether we compare if P3 is just current P -1, right? Then we're trying to see whether P2, right? P2 is possible. It is for example P3 -2, right? So P2 it is possible it's already smaller than p minus 3, right? Small equal to, right? So what we do is that we just do if else, trying to check these three numbers, the last largest previous smaller, right? Largest smaller three numbers, so that we don't need to use tree map to store everything, right? So for this three number, we need the power number as one of that, and also we need a sum, right? Long as sum. That means the largest total damage at this number, right? So what we want is that instead of use tree map, we can just use three p number and three sum number, right? So let's do this. So we still need a count, and we have v1, or what that is a power number, right? Let's say this one as integer dot mean value, and v2 equals integer dot mean value. V3 equals, and also we need a long, right? Sum 1 equals 0, sum 2 equals 0, sum 3 equals 0, right? So we here, what we want is so let's just say pick, right? Pick equals 0. Actually, all we will say this is the base before, right? So let's look at what is the base before. So we'll say if power I minus v3, if this is already greater than 2, right? Then we have pick equals sum 3. And else if power I minus v2 greater than 2, right? Then we just have a pick. That is base before, right? Equals to sum 2. And we'll write else if power I um, actually we can just write else, right? Because for the the biggest last three biggest smaller one, right? We always have should have one satisfy the condition, right? So this is pick, and also pick. This is best before, right? Best before, and pick for pick we should plus equal to one multiply count multiply power I, right? So this is pick, and for not pick, that will be max, but max. So sum 1, sum max dot max, sum 2, sum 3, right? And here instead of, because we do not use tree map anymore, right? And we need to have this kind of v1 equals v2 and v2 equals v3, right? So what we need is v1 equals v2 and v2 equals v3. Now what about v3? V3 will be our current power I, right? And also we should have sum 1 equals sum 2 sum 2 equals sum 3. What about sum 3? Sum 3 will be max dot max peak and not peak. So in the end, we just return sum 3. So let's see. So this should be so let's see, we do not use tree map, just use 3 pair of variables or 6 variables. It's very fast for the result, right? So you'll see the time complexity, because we use that sort, right? So still in log n as time complexity, but space will be constant because we know the tree map, we store the every distinct uh, uh, power as key, right? But actually, we do not need to store that much data. So doing like this way, we'll find the space is constant, and let's also write Python code for this. So we are going to have power spot, and we are going to have n and count, and v1, v2, let's do this. N equals length of power. Count equals 0, right? V1 is V2. V3 equals float IF. And sum 1 equals sum 2. Because sum 3 equals 0, right? So for I in range, and we need to group iteration how count, right? Count should plus equal to 1. And if I equals n minus 1 or power I doesn't equal to power I plus 1, then we're going to have the first, we need to have peak or not peak, right? So peak it's set 0, right? And we'll say if power I minus V3 is greater than 2, then we'll have peak equals to sum 3. Else if power I minus V2 greater than 2, not 3, greater than 2, then I'm going to have peak equals to sum 2, right? And we'll have else. We'll have peak equals to sum 1, right? And we know this is actually previous largest, right? So for peak, we should still add equal to current count multiplied by power. And what is about the not peak? So the not peak equals max sum 1, sum 2, sum 2, sum 3, right? And we are going to have V1, V2, V3 equals V2, V3, and power I. And we're going to have sum 1, sum 2, sum 3 equals sum 2, sum 3, and max peak and not pick. Right. And of course, for every group iteration, we should set this one as 0. And in the end, just return sum 3. Pick sum 3. Pick, no pick, pick. Cannot access local variable. Where it's not associated with a value. Uh, we should those all of this right should be in the if statement. You see, doing like this, we have good performance.